Ok, buongiorno a tutti. In italiano o in inglese? English. So, good morning, everyone. So it's a pleasure to have here Claudia Ghisetti, who is assistant professor, almost associate professor at the University Bicocca. So he's based in Milan. So actually, it's good to have somebody based in Milan also to create connection and networks for future work or some collaboration. Claudia is one of the leading experts in Europe of green innovation, eco innovation. So worked a lot on this topic for several years and published in leading journals, both in innovation studies like research policy and industrial and corporate change, and in environmental economics like environmental and resource economics, journal of clean air production. So the list is long. So and it's not so it's not important here. And now she's moving from all the studies she did in eco innovation, collaborating with several institutions in Europe like the ZW, the JRC, and so on. She's moving on two topics that I think is extremely important topic for the future, which is the topic of the twin transition. So she already has a few work on this, and today she's going to present a new work on the twin transition that, as you see, has an angle again on innovation from innovation study perspective. She's trying to understand more of the twin transition, looking at patent and publication data. So please, the floor is yours, Claudia.
Thank you, Francesco, for the very nice presentation, and thank you all for having me here. It's a pleasure for me to be in this amazing room presenting this work. So the layout of the presentation I have in mind is based on, forgive me for that, on mainly two papers. One has been published, so I will dedicate a couple of slides to that published one, and the other one is ongoing, so I will dedicate most of the presentation on the ongoing study. Both works are been based. I worked on this both work with the same team that is made by myself, of course, Stefano Bianchini at Strasbourg University, Beta, and Giacomo Damioli, former JRC, and now Beta as well. So the idea of today is to try to give you an overview of this concept of twin transition using mainly innovation lenses by combining patent data, so technological data, with publication data, so scientific knowledge base determining this twin transition. So the idea is that of trying to give an overview of what policymakers have been stressed to be the crucial arrival point that is having an economy that is competitive, able to combine what is named a sustainable green transition with what has been called digital transition. So if we have to look at the most relevant recent policy document, so the Agenda for Sustainable Development, the European Industrial Strategy, the Green Deal, the Recovery Fund, the European Digital Strategy, in all these main building blocks of the European policy making, we find an explicit mentioning of the need to combine digital transformation with green transformation. So what has been named by this policy document, twin transition. Now, the rationale behind this concept is that digital technologies may somehow help the green transition uptake, so green technology. So the idea behind, the rationale behind this twin transition concept that, again, I repeat it, emerges in policy document, is not a concept that comes out from scientific studies. This concept of twin transition in the rationale of the policy making is that we can use new digital solution to also helping the society becoming more sustainable, becoming greener. If we decompose this concept of twin transition, then we see that we may find support, scientific support, that certain digital technologies, certain technologies that are building what the OECD calls the digital ecosystem, may actually act as method of invention. So they can help creating new technologies. They can help somehow recombining knowledge in different ways in order to get new technological solutions. So we find evidence, for instance, that artificial intelligence is helping scientific discoveries, is helping scientists to formulate new research questions, is helping scientists to collect and manage data in a more efficient and better way. And it can also help analyzing and interpreting the results. So overall, AI is found to speed up the whole process of scientific discoveries. But it can also help, artificial intelligence can also help to tackle new problems in a new way, in an unconventional way, making, again, more easier to find a new technological solution. Not only AI has been discussed to be potentially support for the green transition, but also there is discussion that also Internet of Things and big data are those parts of the digital ecosystem that help new discoveries to emerge. So for instance, some Internet of Things devices and applications, think about wearable sensors, can allow an easier and faster data collection, and if managed by a functioning computing infrastructure, we can have bigger data to analyze and conclude about new discoveries. So overall, the rationale on the digital side is that those technologies can be recombined in a way to be serving also the green transition. On the other side, we find support on the green side, the environmental side. We find support that those technologies, environmental technologies, are discussed to be way more complex than standard non-environmental technologies. There is evidence that they tend to rely on more interdisciplinary knowledge field than standard non-environmental technologies. So there is a vision that may see green technologies as something that needs also digital solution in order to better evolve and better discover new environmental technologies serving the green transition. So in theory, the rationale behind the twin transition concept is that those advanced digital technologies can be an opportunity also for inventing in the green arena, in the environmental domain. If we move from this theory that is mainly policy driven, but also finds some scientific support to the evidence that we find that has been published on explicitly mentioning twin transition kind of approaches, we find very recent works that are based at different levels of analysis. And here, let me be clear on that. I'm not really sure yet, although I'm studying the twin transition, what is the right and appropriate level of analysis to deal with the topic. We have evidence at the country level. Benedetti and co-authors 2023 show that digitalization is improving energy efficiency in European member states. We have evidence at the regional level, so the meso level. For instance, we have a study showing that AI is favoring the regional specialization in green technologies. So again, confirming this link that digital technologies serve the emergence of green technologies. We have evidence that digital skills available in the workforce can facilitate predicting the emergence of a green regional specialization. And then we also have studies conducted at the firm level, so the micro level of analysis. Firms' investment in artificial intelligence have been found to be supportive of the capacity of the firm to adopt eco-innovation or circular economy related innovation. We have studies showing that the organizational setup, the way firms organize, facilitate the way firm is able to recognize that knowledge and recombine it internally, so be successful in twin innovation. So we have some evidence that scientifically is supporting this idea of twin transition. At the same time, what I think I would like to convince you today about, we have to be aware that the twin transition concept is not without trade-offs. Digitalization, and here I copy-paste a paper with a long list of authors, Kreutzig, among others, Verdolini. Digitalization has historically increased environmental impacts at local and planetary scales, is affecting labor market, resource use, governance, power relationship. So we have to be sure, we have to recognize and acknowledge that digitalization can serve the green transition, but itself, the digital transition, so one of the two components of this twin transition, is showing both environmental bright sides. So in one hand, digitalization is improving energy efficiency, improving environmental monitoring. It can, if you think about 3D printing, it can allow be more material efficient by allowing to print something without consuming all the material needed to manufacture that. It can improve somehow the wasting, but at the same time, digitalization shows clear dark sides. Is massive energy requirements, the need to deplete scarce and rare resources, the production of waste that is not so easy to be recycled, remanufactured, become circular. So overall, the digitalization can has positive can lead to positive environmental impact, but can also lead to negative environmental impact. And the second component, of course, the green transition is clearly improving the environment if we think about the definition of environmental technologies, but also there we have evidence in all this literature on the rebound effect that it's not a clear cut, the final picture that would emerge. So super short, but important to me to start with, is this work that we published this year in Environmental Resource Economics, the title is there in bold, in which what we try to do, and it was the starting point of our research project, we tried to empirically test the environmental impact of the twin transition. So the goal of that study was to basically understand whether at the aggregate level, at the regional level, the green transition and the digital transition were actually pointing to the same environmental direction. And the answer we got in the study is that no, the twin transition, environmentally speaking, makes no sense. Environmentally speaking, the twin transition is characterized by two components that show heterogeneous environmental impact. Digital technologies at the aggregate level, and the study was conducted at provincial NUTS3 level in Europe. At the aggregate level, we find that digital technologies worsen greenhouse gas emission. And by contrast, green technologies improved greenhouse gas emission. Then I will show you a bit more on that. So the first result we got is that the twin transition is not really showing off, environmentally speaking. The second result we got is that when we decompose the digital ecosystem by its building blocks, we find that not all the digital technologies have the same environmental burden. And in particular, whereas artificial intelligence and Internet of Things were not showing any significant effect on emission, on greenhouse gas emission, by contrast, additive manufacturing, big data, computing infrastructure, and robotics were actually those categories mostly contributing negatively to the environment in European provinces. Last result that we get is that when we combine the digital and green transition in the same region, so adding a moderation effect in the empirical estimation, we find that let's say that possessing sufficient green knowledge bases may counterbalance the negative effect of the digitalization. We got there by basically estimating a standard model in which greenhouse gas emission was our dependent variable by using a PRTR data, so we are only able to capture about half of the overall emission in Europe. Only ATS regulated firms are obliged to report data in that repository, so we are only able to capture that about half of the European emission in greenhouse gas. And we try to connect this greenhouse gas emission by the main variable. There are green technology of the region, so we are measuring patent application in green technology that the province, the NUTS3 region possess. the digital patent application of a region, and the interaction between green and digitech. Now, without really going into the details, because, of course, I'm happy to respond to questions, but that has been published, so you can read it yourself. The idea is that we measure it by an instrumental variable to reduce the problem of endogeneity related to green technologies. So the instrument we used were institutional quality of the region and the political orientation of the party who won the election as external to the model for identifying it. And what we got is basically what I told you in extreme synthesis. So if you look at the coefficients associated to green tech, they have negative signs. So possessing green technological knowledge base improves the environment of a region because it reduces the emission. By contrast, digitech has a positive sign. That is, the higher the digital technologies developed in a region, the worsening its performance in greenhouse gas emission. But when interacted, the two variables show a negative effect. So possessing enough green technological capabilities can somehow reduce the burden that digitalization brings to a place. So that was the starting point, recognizing sorry for being fast on that, recognizes that the twin transition that emerges in a policy document is something that, environmentally speaking, is kind of nonsense. Then it comes the second paper, that is the unpublished paper, same team, in which what we try to do is to look at the twin transition with a different perspective. That is, instead of looking at technologies per se, instead of looking at patenting per se, patenting activity, we look at what we call scientific knowledge base. We try to look at this scientific knowledge base with the first aim of providing a mapping of that science base across Europe, across, again, European regions. We try to understand how much this twin scientific knowledge base is spatially dependent, so how much what emerges in a region affects what emerges in close by regions. And we try to understand how much the digital and environmental scientific fields are recombined to favor the emergence of a twin scientific knowledge field. So the idea of this work is to reconcile with all this literature in innovation studies that show that scientific knowledge is an explicit driver for technological innovation. So scientific knowledge has been, and here I'm short on that, is something that can guide R&D activities to make the whole innovative process more efficient. So the idea is there of studying how much this scientific knowledge, the scientific knowledge in this twin domain is building upon prior art and prior knowledge. So the main question we pose in the paper is to understand how much there is cognitive proximity in studying the twin scientific knowledge domain dimension. But before doing that, we also have to acknowledge that spatial proximity in this context matters a lot. In general, spatial proximity matters for technological change. In particular, spatial proximity matters for both digital technologies and digital knowledge, and for green technologies and green knowledge. We have evidence that digital technologies are differently distributed across countries, sectors, and regions. We have also knowledge that the most transformative of the digital technologies ecosystem, that is biotech, are also those digital technologies that are shown to be mostly spatially concentrated. So they tend to emerge in a very spatial dependent way. And the same spatial proximity is relevant also for the green component of the twin transition. Green technologies are highly spatially embedded and are highly dependent on the presence of a local green knowledge base that may favor their emergence. So this is something we need to be aware and we need to account for in the empirical study. What we do in this work is then collecting data on scientific publication in this domain. So we start by extracting by Web of Science, the Web of Science core collection, all scientific articles that have been published in peer-reviewed journals, plus conference proceedings in the 20 years 2000-2020. Based on the location of the authors of each article, we assign that publication to the region, NUTS2. And there we get the three main variables of interest in the study. Digit is capturing all the publications in a digital scientific domain. Based, how did we capture that? We are talking about publications, so of course we lack an IPC classification that allows us to easily flag those publications that are digital. So we had to go for a keywords-based strategy to apply to each and every title and abstract of a publication. So I'm sure you won't be able to read it, but of course I'm happy to give you answer in case you have doubts. So the idea has been to apply these digital keywords divided by the categories composing the digital ecosystem, so artificial manufacturing, AI, blockchain, big data, computing infrastructure, Internet of Things, and robotics. Whenever one or more of these keywords emerge in the title or abstract, that publication is flagged as a digital one. This led us to about 380,000 publications in the sample.
Sorry, Claudia, what do you take the keywords that you use for selecting the publication?
Where do we, good point. This list of keywords was taken from the previous studies in which we were looking at how to flag patent in digital arena. So it's basically a classification that resembles technological application. Is not a purely digital, if you want, word. Is a digital word that talks to technological change. So it talks to technologies. So, and for flagging digital patents, there you have some sort of classification based on IPC codes for artificial intelligence, for instance. But for many of these categories, you lack that classification. So we basically reconstructed based on also what literature does in the previous paper for flagging patent, and we applied that to publications.
Yeah, I have a doubt on this, because if you then you want to see a kind of correlation between the scientific base and the technological base, and you use as a set of keyword the one of the technological base, you superimpose the kind of overlapping of.
Okay, that's okay. That is a question that makes totally sense, but it is not really what we're trying to do. So what we are trying to do is not so complex than what you're pointing to. But so first answer is not, this is not what we are doing, but last answer at the end of the presentation, I will show you that actually if we correlate this variable constructed at the NUTS2 level for publication with the variable constructed at the same level from the previous paper, the correlation is 0.4. So it's not that high, the correlation between patenting in digital tech and scientific publication in digital domains, which is for us a limitation, of course, of using scientific data, but solves probably your concern. I hope so. Okay, she's asking if we have privacy in the list. No, I think we don't have privacy anywhere here.
And the second question is, can you divide the quality of the publication?
Yes, it's something that we do.
Okay.
Stay tuned. Thank you. Okay, so this is for digital. And then for each of these categories, we construct an additional variable that is unbundling the digital publication in AI, blockchain, etc.
Sorry.
Question from.
Just a question on these slides here. So basically, as far as I can see, you have looked at these at only scientific publication. Now, one question that might emerge in this is that in many fields, scientific publication do not matter. So in informatics, for instance, I know from colleagues of the Department of Informatics in Statale, they don't even care about publishing in Web of Science. So they care about proceedings, they care about, the same holds true for physics and other stuff. So possibly this is only a very limited amount of scientific knowledge that actually enters the publication. So for instance, all the gray literature, stuff like that might also be relevant, even more relevant than this, because I guess that in many fields, publishing in a scholarly journal doesn't matter at all.
No, yes, I agree with the point. We include conference proceedings, so part of the story is captured. The full reporting and all this activity is, of course, not captured, but it's not captured for a reason of trying to give the same level of quality to publication and have to rely upon a sample that we can treat in the same way. But I agree with you, and probably this may help us understanding why the correlation between digital publication and patenting is not that high, because probably something that comes out from reporting can help developing technological solution, but is not emerging by using scientific articles. No, for sure. For sure. I mean, we made the choice.
Discussion about not publishing in these journals because you made them profits. And I remember I read an article, I think on The Economist, concerning that an increasing number of scholars prefer to put their paper as soon as they produce it in these archive repositories rather than sending it to journals. So maybe you have access to, I know one is archive. You know,
no, we can try to look at that, try to, at least for a robustness, additional robustness, to see what we get changes dramatically. Yeah, thank you.
Sorry, just because I have experienced that this type of papers, the decisive part is this one. So it's like, you know, the classification part, I think, is one of the key contributions of the paper. So
yes,
actually, yeah. I want to ask another couple of questions. First, a suggestion. There is David Popp that did something similar for green. So trying to classify all the publication as green or not. And he told me that it was really hard to do it because of, you know, the lots of noise that you have. And perhaps you want to have a look at this paper that is published, I think, in Nature Energy, but the working paper version, which is MBR, is better because it's longer. Another point is that here, do you consider as green a publication made by us on the yeah, I mean, I would really strongly recommend to just keep the scientific field that are really needed for science, because I mean, we are.
So stay tuned. Let me finish the way I constructed it, but then I will answer with the table on this concern.
Claudia, another question.
Sure.
Location of other authors. What does that mean?
It means
there can be many authors. Is the corresponding
that we had a discussion. We decided for non-weighting the contribution. So let's say that if me and you publish a work based into different regions, the idea behind the non-weighting is that the knowledge can flow easily to the region in which you and I are located. So the choice we made, and we count, I mean, the total amount will not be one. I mean, we decided for not going for a weighting of the publication. We could do it, and we have the variable in the sample, but the idea we have behind this paper is an idea of knowledge that flows to develop new knowledge, no? So we think it makes no real sense to weight a knowledge by the number of authors that contributed to. I mean, if you discover something, the discovery can apply in your region.
I was just asking, you and I publish a paper, you're in Milan, I'm in Rome.
It goes to Lazio and Lombardia.
To both?
To
so
both.
You count it twice?
Yes.
Okay.
Yes, I count it twice. Okay, I go on. So for green, we had the same issue of not having keywords, but I will look at the POP work actually, because I didn't have it in my list. So we made a list of keywords resembling the OECD FTech. So the idea was to find keywords that were talking to environmental technologies. So the basic list of keywords here cleaned for all the asterisks and different way in which the same term can emerge. We have it along the dimension that the OECD FTech uses to classify environmental technologies. And here we have less publication, 244,000 in this field. And then twin is basically the intersection of the two. Whenever a publication has both one or more digital keyword and one or more green keywords, then it's flagged as a twin publication. And here, of course, the sample by construction reduces up to 7,000 about publication. Answering Marta, we constructed, as the main goal of the study is qualitative, we constructed these variables along 3 different dimensions. The main one to us is, of course, the quantity, so how much a publication possesses in terms of publication in the 3 domains. We want also to account for the quality that we measure by looking at the average of the yearly number of citation that publication receive, and then of course aggregating in at the region. And then with the idea, a super dirty idea of be willing to capture also for the impact outside academia that a publication may have, we constructed a 3rd dimension that we label online visibility, that is based on altmetrics.com, which gives us an aggregate attention scores that is combining in a composite indicator basically how much mentioning in mainstream media, online blogs, forums, social networks, Wikipedia, policy documents, and research blog discussion a publication has. So along the 3 dimension, of course, the picture changes a bit. Before going to the picture and the qualitative evidence we get, what we try to give as a sort of an internal validation to the keywords was, so probably answering to your comment, Francesco, was to try to understand how much those publications were coming from scientific knowledge fields that were clearly related to green technology, so first column. So, for instance, if a publication is in biodiversity conservation, biotechnology and applied microbiology, ecology, etc., energy and fuels, then we are quite sure that this publication is in a scientific field that is clearly environmental. Then we have another set of fields that are potentially related to green, but not sure that those are related. And then there is a set of fields that are unlikely to be green, like acoustic, allergy, anatomy, andrology, all the medicine is there, and all this. Of course, this list is longer than what I can show you in a slide, but to give you the idea of the work that we did. If we aggregate it all in a single summary table, constructing how much the scientific discipline behind our green publication were coming from clearly related to green technology area, we find that about half of those come from discipline that we can be sure are somehow green. 42 of scientific domains are actually potentially related to green. So we may be at risk of using some knowledge that is not so beneficial for the green. And only 5% comes from medicine and all these disciplines that are unlikely to be green. Answering your question then directly, Francesco, we also constructed a measure that captures if that scientific field is an art science or STEM or vis-a-vis social sciences and humanities. And we find, confirming a bit our hope that these keywords at least a bit work, we find that 95% of the study come from disciplines that belong to art science and STEM, meaning that the residual 5% is in social sciences and humanities.
One issue, that's very good. I think that I think this makes everything much more convincing. Why don't you try also to do a filter for the journals? This is quite common. For instance, in all the indicator, try to capture the how people speak about climate change. Just select the 5-10 journals. The same for online job vacancy data. They select just top newspaper, in this case, not newspaper, not journals.
So to better qualify,
yes, Nature,
we can do it to better qualify the
the top 10. So you really take the cream, you know, the top of the knowledge.
If you believe in the assumption that the useful knowledge comes from the top, which is something that is not so easy to defend. I mean, I won't believe in that assumption, but if you believe, I will do it as a robust.
In hard science, perhaps yes. In economics,
yeah.
of course not.
Yeah. And then we did the same by visually inspecting each of the 150 keywords to see if there was one or more keywords that talk mostly to discipline that are unlikely related to green. And it works quite well. So qualitative results, and probably I should speed up a bit because I'm using most of my time here. Qualitatively speaking, if we visually inspect those three domains, we find clearly that, of course, by construction, twin publication has way less than the others, and we can count that we have about 1 twin publication every 41 digital publication and every 31 green ones. But if we look at the attention that academia gives to this domain, we find that those twin publications are found to be of better quality, or at least are cited more if we don't believe this is a measure of quality. And lastly, along the third dimension, the online visibility, we find that green has way more online attention than the other two categories. Visually inspecting these publications, once we assign them to the region, this is what we get, absolute numbers and scaled by population about digital. I'm going faster because I will give you directly the message. Same picture for the green, same picture for the twin. If you were to have this figure on hand, you will notice that most of the NUTS2 leading regions in twin were leading in green and were leading in digital. Partly as expected, because of course twin comes from the intersection of the two. But the study is not ending here, because if we look at the top, and this is the list of the first 28 for visual reason, in twin, digital and green, you will see that most of the regions that are the colored green ones are twin leaders being green leaders and digital leaders. So as expected, there is sort of a by construction persistence in the phenomena that we are studying. But at the same time, we have some regions, 5 out of 30, which is not negligible, that emerge to be twin leaders without having been leaders in green and digital. This is also confirmed in a more, say, statistical way if we build a transition matrix between the first 10 years and the last 10 years. I'm only showing the transition matrix for twin because for green and digital we see strong persistence. Those distributions do not change over time. By contrast, if we look at twin publication, those are publications that show a much more dynamic in time. So we have that half of the regions change the quintile they belong to between the first 10 year and the second 10 year. And as a matter of fact, this is shown here. So the share of European region that host at least one author affiliation in twin domain is upward trend, whereas green and digital are basically not really showing any interesting dynamic, which is partly explained also by the uptake that digital publications show, which is followed by the uptake of twin publication and not followed by the uptake of green publication that are instead decreasing in time.
Just one comment about the regional distribution, because you finished now. I would highly recommend you to compare it with the measure of technological comparative advantage, like the one that Barbieri et al. Did. We also did a measure on production comparative advantage, so where green production is located by European region. So actually, I think that what you show is a bit surprising for this, because there is no Denmark or very little Denmark. There is not a lot of Austria, Sweden. I mean, perhaps you want to compare and try to, you know, speculate a bit, because it seems that there are the areas that are densely populated there, and you said that it's driven by green, but seems more driven by digital. But I mean, perhaps.
So maybe anticipate this, that was in the limitation. So this is not a specialization, but is an absolute number of green technology. So when we compare the number of green technology with the number of green publication, assigned to the region, we see that the picture is a different picture. And in fact, the correlation between the two, whereas for digital, the correlation between publication and patenting was 0.4, for green is way lower, it's 0.3. So I have the feeling that we are capturing the twin transition by a different measure, but we're also capturing a very different story than a purely technological story. And as we are already here, this is what we get for digital. Again, a different picture for digital technology above and digital publications below. And to conclude the point, if we look again at the top leaders, in the first column, green tech, second column, green publication, we find only the green ones are in both rankings, whereas the dark one, the black ones are leaders in one without having been leader in a second. And the same for Digitech. The red ones are the regions that are leaders in both technologies and publication, and the black one are the ones that are not leaders. So point is, we are studying scientific publication, but we are not sure we are measuring actually something that really talks to the technological dimension due to the low correlation and due to this distribution. So based on this evidence that twin publications are much more dynamic than green and digital one, there comes the weakest part of the study. That is, to me, the main value added is the qualitative evidence that it provides, that is trying to understand a bit more this dynamic. So the last part of the paper is try to understand whether the local emergence of a twin knowledge base is primarily driven by either the presence of a green knowledge base or the presence of a digital knowledge base. So the main question we try to answer is, it matters mostly to be specialized in digital or in green in explaining the twin transition domain emergence. We unbundle the digital ecosystem, try to understand if it is true that AI is that technology that is mostly contributing to a twinning of being able to reach sustainable goals with in combination with increasing levels of digitalization. And of course, we try to answer whether this picture changes along the three dimensions of quantity, quality, and online visibility that we constructed. So econometric setting is an easy one in which twin would be our dependent variable, is super endogenous because by construction twin comes out from green and digit. So we're not really posing any causal claim in here. We are just trying to understand which of the two matters the most and which of the building blocks of the digital ecosystem matters the most in explaining twin domain. Controlling for a set of control, the technological development of a region captured by patenting activity, the population density, and the performance, economic performance of the region. Controlling for regional fixed effect, and controlling for the presence of spatial dependence. So the fact that being close to a region that develops knowledge in this domain facilitates the process of knowledge development in the same domain. Out of the models that we tested for, what emerged to be the best one was a spatial autoregressive model. So we augmented the equation by a standard queen contiguity weighting matrix. So it takes value 1 if a region is close by and shares a border with the other, and 0 otherwise, multiplied by our dependent variable. So W twin would be our spatially autoregressive variable. And what we get, of course, we cannot read the SAR coefficient directly from the table, but we have to compute them in terms of direct spillover and total effect. So what we get is, and here, of course, this table comes from multiple estimation table that we run separately. What we get can be summarized in this last column, in which first and second row, we find that green publication, we find that first, both green and digital knowledge bases are relevant in explaining the emergence of twin knowledge bases, but it seems that green matters the most when we talk about the quantity of scientific publication. And second result, that to me is the policy relevant one, if we look at the remaining rows, so from 3 to 9, in which we decompose the digital ecosystem into its building blocks, then it is striking to see that artificial intelligence that was discussed in the scientific literature to be the method of invention that would serve this twin transition is not showing off in explaining the emergence of twin publication. So we find, unbundling the digital ecosystem, that Internet of Things and big data are those categories that matters the most in explaining twin domains, but we find that AI is not helping the story. This is confirmed when we look at quality instead of quantity. So again, green matters more than digital, and AI does not matter. It has no relevant coefficient associated. And it reverses when we look at online visibility, in which it seems that digital publication helps better the twin publication visibility than green ones. Of course, are different dimensions, so it can emerge a different finding. So concluding, what we got in the study was, qualitatively speaking, there is high persistence and high spatial persistence in digital and green knowledge creation, but a much more dynamic observed in twin domains. So there is a sort of a very dynamic process of actors, regions, reconfiguration in this landscape. We show, qualitatively speaking, that twin knowledge is larger, of better quality, and more visible, but that twin knowledge needs both green and digital knowledge in order to emerge, with green showing a bit more off than digital. And we show that not all the digital components are equally responsible for the emergence of twin knowledge. So here, the provocative last point I would like to make before going to a couple of additional robustness is that on the first study, we concluded that the twin transition is, environmentally speaking, not really meaningful. In this study, by looking at how knowledge emerges, we try to see if it is really true that those building blocks of the digital ecosystem that were supposed to be crucial for the uptake of green were actually so crucial, finding that artificial intelligence, that is the most policy relevant component of the OECD ecosystem, we find that this artificial intelligence is not so general purpose, at least in this context. So the provocative question, if you want, is whether we are sure that it is needed to support the digital transition as a tool to support the green transition, if the ultimate goal of the policy making is actually to support the green component of the twin transition. So this is something I show you already. The limitation of the study is that we're not really capturing the same story if we look at scientific publication vis-a-vis technological data. And the correlation of this one, green publication correlates 0.3 with green patent, digital publication correlates 0.4 with digital patent. So we have to be aware that we cannot conclude that the story for AI could be extended to also to patents in this arena, because it's something responding to a very different process probably. But what I can tell you is that we cannot really redo this study using patent data, because we tried to understand whether a patent can be twin, whether a patent is itself both digital and green. But overall, in all the European patent application in the 20 years we studied, we find that only less than 1% of publication can be considered twin. So this kind of study cannot be extended to the technological arena to understand whether it is true the story for AI and extendable also to technologies. I think I can stop here super late, super delay, but thank you for the interest and the attention. Of course, I'm happy to take questions on that.
So please, any questions?
No, please wait for the microphone, otherwise online people can hear you.
Now, when you're working within the spatial autoregressive model, you were taking the W of the twin, but the raw coefficient that is taking you the spatial dependence, you estimated it, and how much that's because you didn't show it. So no, I was wondering, or maybe I missed it completely. So that was
no,
my
sorry,
fault.
I went super quick on that, but not really sure I'm showing. No, the point, no, but your I'm happy to take this question because I can also add something on this. I was very quick on that. We went for a spatial model because results of the test would suggest for this spatial model, but actually rho is very low. The spillover effect computed in the second column is super negligible it is significant, but negligible in the coefficient. And if I compare it with a simple parent a panel with a simple fixed effect, results are basically the same. So we have a spatial model because the theory suggests that there is spatial dependence, and this test suggests the presence of spatial dependence, but rho is very low and the spillover effects are very, very low. So actually, to be honest, I'm not really sure we will keep it as it is because it is the strongest solution, but it's not so strong to show a spatial autoregressive model in which autocorrelation is so low. So we're actually in the moment in which we are discussing where to go. Of course, the evidence is robust also to the exclusion of this or inclusion of this W twin. But of course, at one point we will make a choice.
Okay, thank you. And the other things is that you were taking, so t minus 2 when you were having the equation of the SAR. So it means that you're taking care of the time at t and then t minus 1. So you regress also the regressors, let's say, or so just to clarify, because you went faster and,
yes,
and you were just having the green t minus 2. It means that
we took a 3-year moving average for both twin, green, and digit to avoid an extreme effect due to spikes in the distribution of those variables. Then to give more sort of dynamic, say, twin as a moving average that goes +2, and green and digit, we build a moving average that go backwards. So in t minus 1 and t minus 2. So to let, I mean, of course, this is super endogenous and we are not claiming to be solving any endogeneity problem here. But of course, the idea, the economic idea is that we are using green and digit that are the building blocks for twin to explain twin. So of course, we need to leave some time for green and digit to be translated into twin.
okay, thank you.
Question below.
Maybe I missed the part when you said, but I want to ask you if you weighted the number of publication over the population or over the number of total publication in each region.
Okay, no, sorry, I jumped on that. Here we are using in all the dimension, no, in the quantity dimension, we are using the pure count of publication without any scaling. In the figure, I presented something that was also scaled by population to provide a clearer picture in the sense of giving a qualitative contribution for the study. But in the empirical part, it is a pure counting with the idea that fixed effect, GDP density, and patenting activity would capture the scale effect of the region.
Thanks.
Okay, thanks for your presentation. It was very interesting. I have a question that mostly relates to the first paper. Actually, no, it's already been published, but maybe you're still working on that project for future research. And I was wondering whether using patent data is the best way to capture the environmental impacts of digital technologies, because from patent data, you don't know whether the technology is actually used, employed, or just, I mean, data that reveals whether the firms applied for or maybe received a grant for technology, but you don't know if it has been adopted. So I was wondering whether you could use data on technology adoption. There is now increasing number of database on firm level survey, mostly based on firm level survey from, we know, paper by Semoglu, Restrepo, and so on and so forth. So maybe you can check whether there's at least a correlation between patent application and technology adoption in these fields of digital and green technologies. Thank you.
No, of course, I cannot respond directly. I totally agree with you. Of course, by measuring innovation by patent data is showing a huge clear drawback that you're not sure that this measure is measuring adoption. Of course, innovation surveys are better off, but are not panel. So you have the trade-off having dynamics in time or having a non-adoption data. it could be interesting to extend it. The point is, what we wanted to do was to also to unbundle the digital ecosystem. That is something we cannot really do by pure survey data. We have few surveys that give an idea about whether the firm has adopted AI or additive manufacturing, but at least to me, a panel of European firm in this dimension is not available, so we could not really use it. But I agree with you that we are capturing only invention, and invention is only part of the story of a fully fledged innovation story.
Yeah, and this question, of course, only relates to the first paper, because when you study the creation of knowledge, patent application is totally fine. But when you study the impacts on terms of increase of greenhouse gas emissions, so that is more problematic.
The idea was, is if you want a regional economics idea. So whenever you have a knowledge available, a technological knowledge available, that region may benefit from it, from a purely spillover effect. Then, of course, with the caveat that you don't really know whether you're also using knowledge that has been created elsewhere but enters your production process. So, of course, the study has the acknowledged limitation of not being able to capture for at all for that that dimension.
Can I jump in this discussion, because I think I mean, Enrico raised a very, very important point. I think you can solve this problem. There is a solution that I mean, survey data. I agree with Claudia that it's very difficult to then to aggregate at the regional level the representatives. But you can use import data. So this is the way Asemogo and Restrepo went for Robot. And you can normally what you do, you exclude the producers of the technology. And for instance, for Europe, we know that the producer of the green are just few countries. I can give you for countries, region, account for everything. You exclude the producer of the technology, and then you look at the import of the other, and these are available for everywhere you want, and you map them to region, and then you can have a real exposure to the usage of these technologies, and then you can correlate it with the greenhouse gases. And I think that would be a very interesting, you know, step to go further in the first project. Okay. So sorry, there was a question from the.
Thank you. I will ask you then in the break. I will ask you details on this. Thank you.
Thank you for the presentation. It was very interesting. I found particularly interesting the low correlation between the knowledge production and actually patents production. I think, I mean, I was thinking if it might be a plausible explanation, the idea that, yeah, production of knowledge is spatially concentrated, but not necessarily, but then the regions where this production happens do not necessarily benefit too much from that. So I was thinking whether this is valuable. And also a question: if you are you planning to have a causal estimation of this econometric setting with an IV strategy? Because I was thinking if it's a viable idea to have a shift share instrument where the shares are the numbers of universities in a region over the country, and the shift would be the EU level aggregate of publications, let's say. But I don't know if it's in your plans. I was thinking about it, so maybe it's useful.
No, thank you, thank you. Well, I'm not really sure that this shift share would solve the problem. I mean, universities are not so dynamic in time, so are basically captured by a fixed effect. You're not really showing so much new university in at the NUTS 2 at least. I mean, you may have a new university that changes the distribution of that province, but at the aggregate, we are not really having so many new university in the 20 years. So I think, thank you for the suggestion, but I think we cannot really go there. But I think we will never go into a purely causal claim here, because by construction it is endogenous. I mean, twin comes at the intersection of digital and green, so we cannot make in any way we can make green exogenous or digital exogenous in this context. My feeling is that this paper is qualitative. Then, of course, we also went for more econometrics, but just to give a clearer picture on the fact that green matters more than digit, and AI does not matter so much, controlling for the rest. But I think we cannot be so ambitious in this context to be claiming any causal relation. Thank you. And for the, no, sorry, for the explanation, thank you. I think it can be be useful to consider also this possible
I don't know,
reading.
maybe for a different project, it might be something potentially interesting.
After you, but before there is Edward that is waiting since a lot of time from the audience. Go ahead.
Here I am. Can you hear me?
Yes, can hear you. Hi, Edward.
Okay, thank you. Thank you for the presentation. No, just one question. So it is my understanding that with this study, you wanted to grasp more information and picture the adoption, or in this case, the creation of a twin transition scientific knowledge. My question is, and this you briefly mentioned at the end, so you went for this empirical strategy using scientific literature because with patents you could only identify very few twin transition technologies. I was curious about what sort of how did you try to identify those technologies? Was it because we've discussed this, but it was still on hold, I think, when we first discussed about this, whether it was through cross citations of the patents, or whether through a combination of the two, identification of green and digital, and use them both by the tagging system. I was curious about that, and because I'm working on it as well, so to have a little idea about that. Thank you.
Thank you, Edward. The way we constructed that less than 1% number was on the one side flagging patent applications based on MTech. So green are those those patents in which an IPC or more are related to USD MTech. For the digit patents, we used a similar version of the keyword search strategy that I've shown today for publication, bit cleaned up for flagging for flagging patenting containing in the title and abstract some sort of appearance of digital keywords. We are working on a bit of an extension and cleaning up of this classification for digital patent in a new research direction that we have in mind. We would like to study this twin transition again at the patent level by looking at how much digital technologies help green technologies by different levels of maturity of the green technologies. And in this, we will be looking at citation from green technologies to digital technologies. So for doing this study, we are trying to include more IPC codes for flagging AI, keeping the keyword strategy for digital. Hope I answered the question, but of course, if you have concrete points to be made available on Skype as well.
Yes. One question about just to understand, maybe it was quick and so I didn't get the rationale of this econometric specification, which has twin transition on the left, and as far as I understand, that is a forward-looking moving average for the next 2 years. On the right-hand side, you have green and digits that jointly forms twin somehow. It is they get intersection, something like that. And those are lagged, so they are sort of backward-looking moving averages. So the first question is, why is that? So why is it like because somehow you are claiming some sort of causality and you want to break down endogeneity working with lags? And the other thing is why controls are also entering this way. So for instance, why population enters with a moving average lagged by density, actually not population, lagged by 2 years. It's because it is essentially a fixed effect. So it's
no, okay. No, first bigger question. No, I thought I made it clearer before to answering the colleague, but it was not clear. So the is not answering a problem of endogeneity in the moving average taken at different times. Is answering the concept that you need to leave some time before given digit to appear in twin. But of course, I mean, we could also put it at the same time and nothing would change. And this is something we've done in the robustness. It is probably easier to see I think, if we have this time lag between the two phenomena. But of course, empirically speaking, this is not affecting at all the results that we got. And for the controls, I agree with you that there is no sense in doing that. We kept it for internal consistency, but we could, those are not fixed because GDP evolves in time, so are not fixed. Density bit, square kilometer do not evolve, but population bit evolves, and technological development evolves over time. So not fixed in time, but again, we can keep them at T and nothing would change. We believe it was nicer for internal consistency, but having no causal claim, I think we can play as much as we want with the time -1 and 2 is not, structurally speaking, is not robust, this story.
Okay. Can I also jump in this comment? Because actually the interpretation here, I think, it's a bit tricky, because I'm actually in this regression, you are saying that if you add one more green, one more publication in green, how likely is that this is also twin? Okay, so if the coefficient there is 1, basically all green are also twin, right? Mm-hmm. So yes. The same happens for digital. Yes. However, you have a problem here, because if the size of green and digital is different, but imagine that the size of green is much smaller than the size of digital, is much more likely than one green. I mean, it's less likely, sorry, that one digital be also green, in a way.
Yeah, indeed, I think.
Because it is the intersection of the two sets, basically, you know? I mean, so,
no, yes,
yeah, so you have a size effect that mechanically enter into the coefficient that you estimate in the biggest one of the two sets. I mean.
No, sorry, I agree with the point, but I think more interesting is to go back to here, in which I was showing that green, okay, we have way more digital publication than green publication. So the size is the opposite of what we get. So green has way, you have more digital than green, but green explains more twin publication than it is for digital, which are of a bigger magnitude.
Green is exactly that digital is also green because it's just a bigger set. I mean, imagine that you have 10 digital and 1 green. Mm-hmm. The coefficient, if the interpretation of the coefficient we agree is correct, the maximum coefficient of the digital can be 0.1. Sí. So this is the maximum. So perhaps you just want to reinterpret the coefficient dividing by the maximum possible coefficient. Understand what I mean? So
okay, to rescale it by the distribution of digit and green.
The maximum possible coefficient is the ratio of the two sets, basically. I mean, the ratio of the two. You understand what I mean? Because
see, it makes sense.
Or yes, I mean, to make also interpretation a bit easier, because
easier to read. No, thank you, thank you. I see it. Thank you. Thank you again.